Good day, 3651 students. In this video, we're going to be covering how to use the NIOS II JTAG debugger. We'll learn how to launch the JTAG debugger, how to use breakpoints, how to set them, how to clear them, and what exactly they mean to the debugging process. We'll also learn how to examine variables during program execution. Before we begin, you need your DE1 SoC board powered up and plugged into your USB port on your computer. You need to remember where you saved your NIOS lab from the last video. We need to be able to find a couple of files in there. And then before we begin, you should also launch the NIOS software build tools for Eclipse. And again, please remember to use version 13.1. That is extremely important. Okay, as you can see, I've launched NIOS software build tools for Eclipse. The first thing we need to do is get our NIOS 2 processor back onto our board. The reason we need to do that is anytime you power your board down, you lose any programming in the FPGA. So to do that, we're going to go up to the NIOS 2 menu. We'll select the Quartus 2 programmer, allow that to launch. Once it does, you'll be looking at this screen. We'll go ahead and click on Auto Detect. Make sure that you select the 5CSEMA5, the second option there. That tells the programmer which FPGA model we're using. Click on the graphic representation there with the left mouse button, and then with your right mouse button click Select Edit and then Change File. This is where knowing where your program files from the last lab comes in. It's extremely important. So what we'll do is we'll navigate to where we saved that lab, wherever that may be. Open up your lab folder, and under output files, we're looking for the .sof file that's there. If you followed my lab exactly last time, it should be called NIOS_lab_1 time limited. Select that, click on open. You will get a warning about the time limited nature of the file. That's fine, we can ignore that. Once it is done thinking, we'll click Program Configure and then press Start. You will again receive another warning about the time limited nature. We can ignore that, so just press Cancel. You see that we have successfully programmed our board. We'll go to the File menu and then Exit. It's extremely important that you use that process so that we don't lock up our programmer, which does occasionally happen if you just X out of the program. When asked if you want to save, you can click No. That should exit out and you'll come back into your NIOS software. Okay, now that we've got our NIOS 2 processor running on our board, it's time to create a project so we can experiment with the debugger. We'll go to File, New, select the first option, NIOS 2 Application and BSP from Template. Instead of using the Hello World template like we did in the last video, we're going to use blank project. You need to browse to where your lab was saved from last time and select the SOPC info file. Click Open. Under project name, we're going to call this debug_demo and press Finish. When it's done creating the make files, building all of the project files that you need, you'll have two folders over here, much like we did last time, debug_demo and debug_demo_BSP. Now we need to give our project a main source file. So what we'll do is right click on debug demo, select new, and then select source file. We'll just call this debug_demo.c. Make sure you put the .c on there and click Finish. And what that'll do is create a blank .c file for us. So when it's done adding that to the make file, you'll have a debug_demo.c file that outside of the comments there put in by Eclipse is blank. I've already written some code that we can test and experiment with. You can pause the video here and copy this code if you want, or come up with your similar code. All we're doing is initializing a debug array of 5 values. We're initializing an index with no initial value, also an integer, and then entering into a loop. And what we're doing is taking the index value and assigning it to the debug array at that index location. So location 0 will have the value 0, location 1 will have the value 1, etc. Okay, once you've put your code in, or you've copied my code, however you've gotten code in, it's important that you save it. You can see the little asterisk up here indicates that this file isn't saved. Hit Control S to save it, the asterisk goes away, and then we can right click on Debug Demo and select Build Project. When that's done building, we will again right click on Debug Demo, select Run As, and then NIOS II Hardware. I've included a printf statement in my code, as you can see, and all that's going to do is just allow us to make sure that we got the software onto the NIOS 2 correctly and that it's running. And you can see here under NIOS 2 console that it has sent out exactly what I wanted it to, which indicates that it is on the NIOS 2 processor and running. And next we will start our debug. To start the debug process, we'll again right click on debug_demo, and instead of going to run as we've been doing, we'll go to debug as, and we're given two choices. We'll select NIOS 2 hardware, and what this signifies is that we're actually running the program on the processor and debugging from there. When this window pops up, confirm perspective switch, you can click yes. That's just Eclipse asking you to change the layout of the window from the programming layout to what they call the debug perspective. This is our debug perspective. Over here in this tab under debug, we have a lot of what's running behind the scenes, the GDB server, the thread that the processor is currently running in, the thread that I should say the debugger is running in, that sort of information. It's not something that we will consult frequently, not something that you need to worry about too much at this level. Over here we have what's known as our watch window. We can see variables as they're initialized. At this point in the program, we can see which variables have been initialized. If they're initialized to a certain value, we can see that. If they haven't been initialized and they just take that kind of garbage value that you talk about in your C classes, we can also see that. We can see any breakpoints that we've set here. We'll get to those in just a second. And you can also see the registers running on the NIOS 2 processor. General purpose registers, control registers, are all listed here. If you're curious about exactly what those are or how to set them, what they mean to the NIOS 2 processor, Altera's NIOS 2 documentation is extremely thorough. We'll take you through all of that. If we look down in this window, you can see that you actually have a depiction of the program currently running on the processor. You can see this is exactly the C that we wrote. The debugger's nice in that it allows us to look at this C interpretation rather than at, say, the assembly or the bytecode interpretation. Right now, this green bar and this blue arrow here indicates that our program has executed but is halted at the top of this for loop. We can see up here, again looking in our variable windows, that we have initialized our debug array. We've also initialized our integer index, but we haven't assigned those any values, as you can see here. And if you expand them, as I mentioned earlier, you can see that they have really just taken on those garbage values. These are not anything that we've assigned. I would bet good money that if you're following along and doing this with me on your computer and on your NIOS processor, these are probably different as well. You can see the same with our index. We never assigned it a value of 511, but again, because variables are not automatically initialized to 0 in the C language, it's just picked up whatever garbage there was in the memory there. As I mentioned previously, our program has halted at the top of this for loop, so I think the next natural question is, how do we make the program proceed? And there's a couple of different ways. The first technique I'm going to show you is to actually step through the code so that we can see what's happening to our variables as we step through this for loop. So again, just a quick glance over here to our variables, we can see that nothing's been assigned a value. We're going to go up here to our step into arrow, and we're going to click that once. And you'll notice that that advances our code down into here. Now this line has not executed yet. The arrow is stopped here. It doesn't execute until we pass off of that, but you can see here that in our for loop where we set our index value to 0, that has happened. We'll click that again, and as it steps back up to the top of the for loop, you can see that it has assigned debug array 0 the value of 0. I'm going to click this a couple more times here. We've assigned the array value 1. We've assigned the array value at location 2 to 2. So you can see that we can just follow that along. The index variable increments, the array locations change. We have not gone to debug array position 3 or position 4 yet. You can see those are still garbage variables. So if we're in the debug process and I've determined that this is working exactly how it is, if I've got a really large loop, let's say that instead of taking this index simply to 5, maybe I'm taking it to 1,000 or 10,000. I only want to check the first couple initial values. How do I continue on? The best way to do that is to go up to this little green arrow and click resume. Resume will take you out to the end of your program or to your next breakpoint, and you can see that when the variables here disappear, that's an indication that we have halted, we haven't halted, we have completed our program execution. Down here on our NIOS II console, the printf statement was executed, and we have been given exactly what we expected from that printf statement. Okay, so suppose that in the course of my program debugging, instead of stopping up here at this for loop, I want to stop someplace else. The debugger is always going to stop here at the for loop, but let's say, for instance, that for whatever reason I need to stop here at this printf statement. To do that, I go to the line that the print statement is located on, and over here in the blue area, double click. That adds a little blue dot. That blue dot is our breakpoint, and a breakpoint is just that. It's where program execution breaks. So now that I've set my breakpoint, once I begin my debugger, as I come down through this code, I'll stop here at the printf statement. So we'll go back up here to our little debug icon. We'll select debug_demo. That'll restart our debugging process. You'll notice again that I've come into the top of this loop. Let's suppose I've debugged my loop. I know everything there is working, so I can just go ahead and use the resume button here to get past that, and now instead of concluding at program termination as we did last time, we've actually stopped here at the printf breakpoint. There's kind of two important things that we can do here. We can use our step into or our step over command. If I use step into, I'll go ahead and demonstrate that here. You'll see that it actually pulls up the printf statement from printf.c. You may want that. If that's the case, you would use step into. If that's actually what you don't want to happen, instead of using step into, you would use step over. By using that step over command, then you actually would skip the printf statement and continue on your way, either to your next breakpoint or to program termination. The important part is if that's an external library call, it's a call to another function you've written, and you don't need to dig into that. You can actually just use that step over command. To terminate our debugging session, we'll go ahead and click here to terminate. That shuts the debugger down. It's important to do that. If it hasn't automatically reached program termination, you need to terminate the debugger. Otherwise, you're not going to be able to get back into your code programming functions. Once you've clicked terminate, you can go up here to Window, select Open Perspective, and then NIOS II. That throws you back in here. You can see, by the way, just as a point, that your breakpoint is still selected. Remember to either keep that selected or unselect if you don't need it anymore. It can be a little bit frustrating when you jump into your debugger and realize that you've still got a bunch of breakpoints set that you no longer need. So that's the NIOS II Debugger. If you have any questions, you can email Dr. Connors. You can ask him in class, or you can certainly email me as well.